In this video, we'll briefly discuss how Begonia stores metadata about recordings. So every time that you have a recording, such as a microscope recording or perhaps some other file, you sometimes want to associate other data with that, like data that describes the data you have. Let's say that you have made 5 recordings and each one of them were of a different animal or a different mouse. You want to associate some information on those recordings about that mouse or perhaps the genotype of the animal, then you can see this as metadata to be connected to those data files. It can also be that you want to associate all kinds of other data, such as traces that are derived, data traces that are derived from ROIs in their image recording. And what we do with Begonia is that we offer a very simple but quite powerful metadata mechanism that allows you to both store such derived data and, well, basically anything that MATLAB can offer can be stored as metadata. And then if you want to, you can continue working with that data also without the raw data afterwards. So this is what we call the data location. And the data location object itself is located in the code, Begonia, and data management. And in this namespace, you'll find the data location and something called off and on path engines and also file path engines. And these are connected to each other. You also have a class called a data location adapter, which is interesting and you might want to look it up in the documentation. At its core, the data location is basically just an object that takes a path and creates the ability to store metadata on that path. So the path to the object becomes the initial primary key in this database if you want. But I'm going to show a practical example and then we'll discuss a little bit what this means. So here we can start with these 5 trials. 3 of the trials are stored as MOT objects. So this could, for instance, represent a TIFF file that came out of a microscope, and another one for a second trial, and another one for a third trial. Some microscopes output directories, and in that case, the trials would look something like this, and there would be image files inside those directories. So what we're going to do is we can open each one of these as a data location. Without looking at the actual data inside of it, we're just looking at the metadata. So I'm going to shift right click this file and choose copy as path. Then I'm going to do and create a data location. So I'm going to create trial1 equals Begonia, data management, and data location. And then I'm going to add the path here. Oops. Guess I ended that code prematurely. Like that. Here we go. So as you can see now, what this command here to create that did is that it returned me a data location object. This data location object has generated a unique ID. And that means that even if this path changes, you can use this ID to relocate this object if you store it somewhere else in the file system. This happens to every data location initialized. If we look over here and see what actually happened on the file system, is that you now have, in addition to trial1.mat, you now have a trial1.metadata directory. And this metadata directory contains the metadata that you write about this file. We're going to create one now for 2 and 3 as well. So we'll just repeat the last command, trial2. We're going to do it for trial 3. But now things are a little bit different for trial 4 and 5, which are directories. So now we have these associated directories for the files, but if the target path is a directory, the strategy changes. And once we create trial number 4, no associated directory is created, but instead the directory is created inside that directory with the metadata. We'll do one more for the 5th one since we are at it. So in our workspace, we now have 5 data locations. And they are different in the sense that some of them write to an associated directory, others work inside this directory. If we have a look at these data locations that were returned, we can look at the last one here for the file, and it says the storage engine is file path engine, data location storage engine, file path engine. However, for the trial number 4, which is the directory, we end up with an on path engine directory. on-path engine data storage engine. And this illustrates that principle that I'll show in a moment, that the actual mechanism for saving metadata can vary, and you can create these engines for yourself. So for instance, if you in your project and your organization has a very, very different strategy, such as a relational database for metadata on the files that you've stored, you can actually create one of these metadata engines for yourself and maintain compatibility with Begonia. Okay, so let's have a look in one of these. We're going to look at the trial 1. We can clear the output so things become a little bit more clear. Trial 1. So let's say that we want to associate now with this file here. We want to associate the variable. We want to associate the genotype of the animal that was used. So we're simply going to take save var genotype, and we're going to say wild type. And that's it. So right now we have saved into trial 1 this metadata wild type for the genotype. Let's say that we also want to, let's say we want to have a trace. Then we can just generate 1000 values like that. And we've saved a trace as metadata to this trial. If you now go to trial 1 and say saved vars, to get a list, we can do one of these little accents to see it as a vertical list, because they say vars. Sorry, saved vars. And we'll see that we now have both genotype and trace saved on trial number 1. But if we swap it out and look at trial number 2, that data is not there. So in this way, you can do an unstructured saving of literally any MATLAB object onto another file. And this proves for us to be very, very powerful. And we use it for essentially every step in the processing that happens in Begonia. I'm going to show one more trick. If you just have a variable called genotype, and you say that that is knockout, then you can actually, let's say we want to save that for trial 2, you can just simply do save var, and then you can do knockout. And if this variable exists in your, you can say genotype. And if that variable exists in your workspace, then that's the variable that gets stored. So if you want to go now for trial 1 and we want to load the variable that was stored called genotype, then you get wild type. And if we do the same thing for trial 2, we get knockout. So what actually happens is that the on-path engine and the file path storage engines goes into these metadata directories, and they store in the metadata directory these variables as mat files. This means that you can store several gigabytes of information here as metadata if you want to. So if you have derived data, statistical data, traces, things that you have extracted from image recordings, you can take these metadata and attach them to files very, very easily. We have one more powerful mechanism to demonstrate this on. Let's create a data locations list. We're going to create equals trial 1, trial 2, trial 3. Then we have the ability in the system to open these with the data manager application. So we can go dataman start and give it the data locations. So there's very little information in the default view here now in the data manager, and the reason for that is that they don't have names and tags and all these things that the data manager expects. But we can go into view, go to variable picker, and now you can see genotype and trace are two possible values that you can put here. So we can put those in the front and apply. And as you can see here, using Dataman, we now can visualize this data on the data locations as a spreadsheet. In fact, if you go into the variable picker, we put an exclamation mark here on genotype and apply, then that variable now becomes editable. So we can actually add one for the last trial here. So this is wild type as well. And now we save that and we directly edited that in the editor. And as you can see here, traces can also go, basically any type of data can be stored in this manner. There's one additional thing, and we'll look into that in a later video, and that is that once once you have data stored like this, once you have things in data location, you can change from on path to something we call off path, and then you'll take that metadata and put it somewhere entirely elsewhere on your file system, perhaps on another external faster drive, for instance. So let's say at this data, you have thousands of entries, thousands of recordings. They are really heavy, several terabytes. Maybe you don't want to have access to that disk all the time. And then you can take the metadata and put that on a faster SSD disk using something we call the off-path engine. We'll do a video on that later, but for now, just remember that data locations are metadata. Is a metadata mechanism that allows you to store arbitrary data associated with your data on the drive, adjacent to the files, or also on other locations, such as another disk, and you can view them in these data managers in a spreadsheet view, and this proves very useful for many projects.